going live.
All right. Welcome, everyone, to this first episode of The Edge of Things for the year 2022. I'm your host, Frédéric Desbiens. I manage IoT and edge computing programs at the Eclipse Foundation. And today, with my guests, we'll try really to explore together the IoT landscape. Now, we've got three excellent panelists there, and we'll give them the opportunity to introduce themselves because, well, obviously, if you've been around on watching those series, maybe you saw some of them, but maybe not all. So let's start with you, Benjamin.
Thanks, Frédéric. So my name is Benjamin Cabé. I'm based in France, as you may tell, and I'm working at Microsoft on the Azure IoT product team, and more specifically, all things open source, open hardware, robotics, AI, TinyML, like anything that can help folks build IoT solutions in combination with whatever stack they're comfortable with, and typically open source. So I've been doing IoT for too long, probably. I was around back when we started Eclipse M2M and Eclipse IoT with pretty much everyone on the call. It's going to be interesting to talk about what's happening these days and what's next for IoT and whatever other buzzword might replace IoT in the near future, because I think IoT is not going to be a thing anymore soon enough, right? So that's me.
Yeah, we'll have to search for a better term for sure. Mm-hmm. All right, next is Jan.
Hello, my name's Ian Craggs, and I'm the project lead for the Eclipse Paho project. I've been project lead for something like 8 years now. I contribute and maintain the MQTT client, which is part of that project. I'm also leading the standardization of MQTT-SN, which is an associated protocol to MQTT. And we're hoping to have that completed sometime this year. Also part of the standardization of the Eclipse Spark plug specification, which is also MQTT oriented and to do with the industrial internet. We might touch on that in the discussion later on. And I recently, in the last couple of years, retired or semi-retired, but I'm continuing doing all of this. So I'm not sure whether I'm retired or not, but I'm looking forward to an interesting discussion as well.
Excellent. And last but not least is Andy.
Hello, Piper. And I was involved way back at the beginning with IBM's contributions of MQTT to the Eclipse, and I worked with folks on the call around that. So I was the initial Paho. I remain a hobbyist around IoT and deeply interested in various things. You'll find me on my weekends blogging about various bits. On the Eclipse side, I'm really still always interested to see what's going on with Paho and Sparkplug. Really fascinated as well with some of the work kicking off around IOFog. And I'm going to forget the project name that I was just looking up beforehand. Apologies for that. So I think there's some really fun stuff happening coming up ahead of us in the next couple of years. Looking forward to talking through some of that today.
Excellent. And as you can see, we've got panelists with plenty of experience who's been around for quite a while in both IoT and open source. So we should have an interesting discussion. And to structure this conversation today, we decided together when we were preparing this panel to really focus on three main topics that you see on the screen right now. First one will be constrained devices and networks, talking about trends in that particular space. Then we'll broach the silicon crisis, the fact that it's so hard to find hardware and what you can do about this. And this will dovetail in a conversation about even different approaches to design and test and validate IoT solutions. And finally, we'll close this off with a conversation around emerging languages and technologies in the space. Of course, people in the audience, we expect you to be alive and present during this conversation. So don't hesitate to ask questions or make comments in the chat, and maybe I will try to inject a bit of that in the conversation as we go. So don't be shy. The four of us are there to give you a good show. So if you don't tell us what interests you, we won't be able to, tweak the conversation. Now, before we start with the first team, I would remind you that the CFP for our Virtual IoT and Edge Days 2022 event is open right now. So if you are in the audience and you are interested in presenting about an IoT and Edge topic related to open source, then please click the action button at the bottom of the window and you will get to the CFP page and get the details about how you can submit a talk to our virtual event, which will run at the end of May. Okay, with that said, now let's go and jump in right in our conversation. So the first theme really that we decided around was, generally speaking, the space of constrained devices. And specifically the fact that there are several interesting new technologies, specifically in the networking space then. And we discussed things like LP1, LoRaWAN, MQTT, and MQTT-SN that Jan mentioned, and also the impact that AI at the edge can make. So, Benjamin, you were the one in our prep call that mentioned LP1. So what do we mean when we say LP1, and why is this so important in the IoT space right now?
Yeah, I said we would, I'm not sure how many buzzwords or how many market trends we will stay away from or actually like dive into, but for the past decade or so, Ian, Andy, yourself, like we've all been talking about those billions of things that are going to make up the Internet of Things. And I'm not sure we are there yet in terms of numbers of devices, but there's only more and more devices that are connected. And historically, like this has been, and back to the machine-to-machine kind of old term, it's been based on kind of like good old Ethernet, Wi-Fi, like good old internet, but it's not necessarily what scales when you want to connect sensors that might be in super remote locations that are battery powered, that need to work out of batteries for years and years. And so, I mean, there's more and more use cases where at the end of the day, the IoT solution, it's all about getting the data as in really like the insights into the cloud and into the IT systems. And for that, you probably need TCP/IP, and you probably need to like rely on good old internet. But ingesting the data that's coming out of those battery-powered sensors, it's sometimes it makes a lot of sense to rely on communication protocols like radio protocols that are not Wi-Fi, that are not TCP/IP based. And many of you probably have heard about things like LoRaWAN, like you mentioned, and network providers like the Things Network and Ilium. And essentially the technology there is all about making it super like as easy as possible to have a reliable network for really, really small payloads. We're literally talking just like a few bytes of data, right? And so what's interesting as a challenge for the industry is that when you have really small payloads and very battery efficient devices, that's great because you essentially enable those billion devices to talk. But how do you bridge that to the IT world, right? And how do you build on top of existing solutions that may be based on MQTT? And how do you keep track of the semantics of the data as well, right? If you're sending just literally a few bytes of data that say something along the lines of 70, is this 70 integer? Is this a temperature? And if it is this expressed in Fahrenheit or in Celsius? And so, there's certainly a lot happening in this space. A lot of the technologies there, I think, at the communication protocol kind of level, like LoRaWAN is pretty mature and pretty neat in terms of what it enables in terms of security and so on. But I think, and I'm sort of throwing the ball at you, Ian, like, how do you see MQTT playing a role in an LP1 context, or is this suited, or is this what you guys are working on, maybe in the MQTT SN kind of specification? Yeah, what do you think?
I think it's very applicable. In fact, one of the main reasons that we're pushing ahead with MQTT SN standardization is because the other main contributor of the co-chair, apart from myself, is part of a company who's using MQTT SN over the telecoms infrastructure. So the same telecoms infrastructure that uses or supports SMS messaging. So basically, it's available everywhere in the world. So even in those remote locations, if you've got a cell phone signal, then you have access to this sort of messaging technology. And they're using MQTT SN as a way of getting those messages into the MQTT infrastructure and using an MQTT-like protocol right down to the edge. So for those people who don't know, MQTT SN is an MQTT-style protocol. It's designed for non-TCP networks. So originally, it was applied to Zigbee, mesh networks, and UDP. Those still apply, but any sort of underlying transport that has those same sort of characteristics as UDP can be supporting MQTT SN over and above that. So I think this is, very applicable because, and potentially in conjunction with Sparkplug, which is another specification that we're working on related to MQTT, which defines payloads. So that can potentially fit into this world as well, because you mentioned interpreting the data, having tags on this data to say, what are the units, where does it come from, what sort of device does it come from, and Sparkplug can give you all of that. So Sparkplug combined with MQTT SN and MQTT can cover all of those bases from the cloud provider right down to the smallest edge network. One observation I always find interesting is with constrained devices is that we always talk about these billions of devices, but and whether they're going smaller, right down to the smallest battery-powered devices, but they're also getting more powerful at the same time. And so there's this two-way flow, as I see it. Like a Raspberry Pi style platform stays the same price, but gets more and more powerful. But also you get these really low-powered devices, which are even more constrained. So you need a different sort of development paradigm for those sorts of really small devices. So it's a really interesting aspect that you get that divergence.
And we were having a little chat right before starting this conversation, and you mentioned the Raspberry Pi.
You mean when I was struggling with the conference system?
Yes,
I couldn't join.
Yeah, but we were discussing hardware specifically for constrained devices, and we were asking ourselves the question. If I'm getting started, okay, I can pick a Raspberry Pi or evaluation board for a variety of system of chips from a variety of vendors, and that's nice. But if I'm going to production, then maybe it's a different game. And Andy, you had an opinion specifically on that I found interesting. So maybe you can share it with us.
Well, thank you for saying I have an interesting opinion. Yeah, I think this blends it slightly into our second topic, actually, where we were going to talk about the silicon crisis, and so forgive me that this is going to sort of bleed across, because I think there's a lot of relevance here, but I don't want to. At the same time, I do want to come back, if we want to some of the TinyML type conversations that Benjamin was bringing up under the sort of the constrained side of things. Mm-hmm. On the silicon side, one exciting thing is either yesterday or today is Raspberry Pi's 10th birthday. Because it was born on February 29th, and it's not a leap year, so that's very exciting in itself. I think, Ian, your observation around, or the observations you've heard from others, in fact, I think that perhaps the Pi is really good for prototyping. And some of the things you just said around there being this, yeah, I think you're right, there are these two forces at work. As you were both talking previously about the networks and MQTT SN, I was thinking about some of the devices I've played with in the last couple of years. There's a small board called a Cricket, from a company called Things on Edge. Funnily enough, we're on the Edge of Things talk panel. So they're a company based in the UK that make this very, very small board that you can run off an AA battery for, allegedly, because I'm sure you can, but I've just not done it yet myself, for a year. That just wakes up, will send an MQTT message, it's got that on board, from, let's say, a one-wire sensor that's attached. I keep meaning to do this to my garden pond, to be honest, but it is connecting, I think, on a Wi-Fi type protocol. On the other side of things, I'm seeing things like the Note carrier from Blues Wireless. So those are radio type boards rather than Wi-Fi type boards. So that it will enable you can run them on multiple carriers. So the Pi is one. I've got the Pi Hat. I haven't yet played with that. But if you think about prototyping, the Pi is great because it's so flexible. You've got all those GPIO pins. You've got all these hats, which are multifunction in themselves very often. I mean, yes, okay, you might buy a hat which says it's an IoT hat, but it's very likely to have a bunch of different options for you to plug in and play with and learn and perfect your solution. One of the things that I've been looking at, again in my hobby, my personal life more recently, has been chips and products from manufacturers like Nordic Semiconductor and Espressif, who have really been expanding their ranges. And now all of this is affected by the lack of silicon. I saw a tweet last week from somebody commenting on the growth of Pi prices because of the shortage and the fact that you can't get the compute modules easily at the moment, or even the regular Pi boards. The Pico, the microcontrollers seem to be in relatively decent supply, but I'm seeing more people doing more with the Pico chips than they were previously. Now you can't run Linux, or you can kind of run a kind of very cut down, operating system type thing on a Pico chip on an RP 2030, but 2040, so beg your pardon. But you can't run full blown Linux, which is what you're running on the Pi board. Similarly, if you look at the Espressif chips, they're running free RTOS. There's a project which we might talk about some more later as well called TOIT, which is, or TOIT.io, which is proposing to be essentially a fleet management orchestration layer for containers running on ESP32. So I think there's some really interesting stuff, both on the relative cost of increasing power, as Ian mentioned, with the Pi boards or equivalent themselves, and also at the other end of it, the very, very small boards that I've been playing with increasingly. Yeah, I think that's where I want to start playing with MQTT-SN and whatever else there might be, and building bridges between protocols. I've always been interested in the bridging aspect.
Certainly. And so when we look at this, it's fascinating, yes, to see how powerful even the cheapest hardware is becoming, and at the same time, yes, that it's difficult to procure for the time being. Now, in an AI perspective, we talk a lot about deploying AI at the edge, and obviously those powerful microcontrollers or even lower-end boards that can run Linux are certainly helpful there. And there you have simplified software stacks that are optimized to run environments like that, and then AI accelerators. So if I want to get started and figure out what's good for my use case, what should I do then?
Well, maybe you should start asking yourself whether it is really AI that you need, or how much of like a really, really smart machine learning algorithm you need, because oftentimes like it might be as simple as having very simple signal processing that, yes, at the end of the day might be implemented by means of a really reasonably small neural network, but the signal processing that you want to do is just, hey, I'm going to like have an accelerometer monitor the vibrations of some piece of industrial equipment, and I don't want to send like 100 hertz of accelerometer data to the cloud by means of LoRaWAN, because, well, I can't. Like it's not going to work. What I want to send is a signal, right? The internet of signal, ring a bell? Andy, I've heard you talk about the internet of signals before. I think probably a good 10 years ago. But that's exactly what it is, right? You want your IoT device, your edge device, to turn raw data into meaningful data. And yeah, I mean, sometimes it's just as simple as looking at the accelerometer data and finding or identifying a trend that's there and shouldn't be there, and that's your alert, right? And that's what you're going to send. And so, in practice, like, it might be a good old sort of if then else kind of processing of the data. If you kind of know what you're looking at, if you don't know what you're looking at, yes, machine learning and AI are going to be helpful. And in that case, I mean, it's probably going to be some variation of TensorFlow Lite for microcontroller that you want to look at. And there is a wide variety of tools on the market, and most of them being open source, by the way, to just help with taking away and removing the complexity of understanding what the neural network, like what is the architecture you should pick for your AI model and things like that, and just like be more use case driven and be like, hey, this is how my accelerometer data looks like. This is how I would like to associate this raw data. This is the kind of insights I would like to get. Like, this is the data corresponding to no alert. This is the data corresponding to alert because there is something bad going on with the machine, and you can like pick up the best model and train it. And oftentimes, like, either you end up with something that is effectively in a neural network and effectively some kind of ML model, but that's going to be really small, and that's going to run on the device by means of TensorFlow Lite and a few kilobytes of memory that will need to be dedicated to the work. Or you will have figured, by the time you've used AI tools to look at your data in ways you hadn't looked before, you will have realized that, you know what, you don't need AI at all. Like the vibration data, you just need to pick up whatever threshold, and whenever that particular threshold is crossed, it is like you can be 99% sure that this is an alert, and maybe that will work too. So that's and we might come back to that with sort of a pet project of mine that I've been working on. I think this kind of relates to all the topics we're covering today. But yeah, long story short, it's really fun to start looking at what doing AI-like kind of processing at the edge enables. And yeah, there's lots of cool open source tech there.
So I have an observation or a question about that. Is, you know, the more analytics that you do at the edge, the processing to reduce the volume of data that you're sending, the more that you're potentially hiding how that, you know, we all know that AI models can be unpredictable at times, and so certain data might cause it to behave in a way that you hadn't predicted. And then at that point, you want to go and analyze what actually happened. So you need to go and look at that original data to figure out what happened. So under those circumstances, what would you do? Would you go back to that device and say, right, okay, you've got some logs, now send them up to me, because I really just need to know what happened and figure out the way to fix it?
Yeah, could be an option. I think there's probably maybe three options. One is what you just described: figure out a way to have the device not forget about the raw data that might prove useful later on. If you can afford it, if your device has both some kind of LP1, like super constrained battery powered connection, you leverage that for just sharing the insights. But maybe once in a while, you know that it's going to hit your battery, but you connect using cellular to upload some batches of raw data. That could be an option. Or what is actually possible is to do training or so-called reinforcement learning on the device itself, right? And you can also take an initial version of your AI model that does a reasonably good job, but you know that it's not necessarily fine-tuned for a particular machine or for a particular sensor that might not be exactly calibrated just the same than the one used for the initial training. and you can do that, or you can do a bit of all of the above, right? You can you can do that too. So yeah.
Yeah.
And I think one interesting aspect in what you just described is the fact that it's so important when you're thinking about solutions like that to think about reporting by exception, right? The fact that you get so much data, you don't want to transmit that in real time to the cloud, and you need to make local decisions. I think that's central to, well, most of the things we do in IoT, and especially it's a particular obsession of the guys working on the spark plug protocols. We literally have that wording in the specification. All right, so let's continue now on our way on our second topic, or coming back to it, since we broached it a bit with Andy's comments on hardware. So certainly right now it's hard to get the hardware that we want to play with. I've been waiting for the longest time for a PlayStation 5. Okay. But certainly, we don't see it just in the consumer space, but in the enterprise space as well. Specific models of computers, of MacBooks, or whatever are hard to find. So, given that, when we were prepping this conversation, we discussed various ways to go around that, or even to make, generally speaking, the IoT solutions that we work on better in a variety of ways. So there are tools that you can use, for example, to simulate hardware. There are things that are called the FPGAs that you could leverage to have hardware that you don't actually have, and we will elaborate on that. So given the current crisis, what kind of tools can be used there, and what kind of approaches can be used there to go to market in a reasonable time, given the constraints that we see right now?
I think it's the crisis doesn't help, but it's just in general, like, what's the time to hello world when you want to build an IoT solution, right? And there's tons of like great open source projects at Eclipse and in many other places, and lots of like samples that those projects provide, Arduino based, Raspberry Pi based. They're on GitHub. You open the GitHub repo, and then what do, right? You need to clone the project. You need to hook up your device using a USB cable or whatever, and you need to have the device. That's for sure. So to me, it's more like, generally speaking, like, how can we get to the point where we can do the equivalent of Docker run blah blah blah, but for an IoT device, right? And running and emulating the computing aspect of it shouldn't be too difficult, like especially for something like a Raspberry Pi and a Linux-based device. That part is not terribly hard, and even for like ARM-based microcontrollers, there's good technology to do just that. What's missing then is emulating the peripherals, because IoT is all about the sensors and the actuators. And personally, like in the past 12 months or so, I've been pretty happy with some really cool open source technology out there. One project is called Renode, and it actually comes from the RISC-V community initially, but it allows to address like tons of architectures and tons of types of peripherals. And Walkwi is another great example, because this one is actually all web-based. So I could actually drop a link, maybe I should drop a link in the chat, where you could just like have whatever sample ESP32 based or Arduino or Raspberry Pi Pico, and I could share a personal project of mine with potentially connections to Wi-Fi and to the internet, potentially interactions with an LCD display or a temperature sensor or whatever, and you could actually play with it with the exact same code that you would be running on the device eventually, right? And to the point where you have ways to do debugging and to sniff the wireless packets and things like that. And I think it really helps with the productivity, right? If you combine this with things like Eclipse or GitHub Codespaces, or like any kind of real cloud-based IDE, then not only do you have like a web-based simulation and interaction tool to interact with your simulated device, but you actually have a full-blown IDE. so you can actually hack some real code, not just like test an IoT project in kind of a read-only fashion where I would send you, Andy, some sample of what I've been working on, but you wouldn't really modify the code because like doing it in an online HTML editor would be a pain. But if you have a real IDE, then that's a different story, right?
So could we say then that there's a developer side to this story and then a device manufacturer or even software provider side to it, in the sense that if we have tools like that that enable you to simulate an actual device or its APIs and its sensors and its connectivity, then as I design the next generation, let's say, of my solution, I could offer to outsiders, let's say, a model of what I have in mind and tweak it instead of burning cycles to try to come up with release candidates of the actual hardware and things like that. Would that be a good approach?
I think it's an approach. It's something that I've seen. I don't know how deliberately it's being applied, but it's certainly something that I've seen happening recently. There's been a number of sort of boards that are, small, more accessible boards featuring chips like ESP32 or Nordic. With a few, and the manufacturers kind of put them up on a marketplace and see who picks them up and builds something interesting, and then maybe get in touch with the developer, the software developers, and the community that's been built up around it, and see what they can iterate into a future creation. I think it would be really interesting to see that same approach applied in a more practical level than outside of the hobbyist area, which is what I'm currently sitting in. I've been a little bit disappointed, to be honest, as a hobbyist, that a lot of the hardware is kind of throw it over the wall. Hey, this chip company has got a new chip. Let's put it on a board and stick a few pins around it and see what people do with it. And whilst I'm a big believer and always have been in open source and the community's ability to build interesting things together around, an odd thing, for example, an odd piece of hardware, you kind of need a bit more detail. You need pinouts, you need schematics, you need more information about how things are expected to work. One thing on the subject of, just flipping back from the question, Frédéric, to what Benjamin was saying, I think Wokwi is fabulous. It's great. It covers a number of different boards. Is very visual. I'd also say that something like Microsoft MakeCode, if you're really wanting to start out and do something basic, is really good and really extensible for different bits of hardware as well. There's been a few of those that have come out, but again, you then sort of end up needing to come into a more industrial mature IDE to do some of the of the packaging for production and distribution, testing, all of the things that you might expect in a tool chain. I think the other thing I wanted to pick up on from what Benjamin was saying, I'm going to go blank as I'm saying so many interesting things he just said. I'm going to pass across to somebody else.
Cloud-based IDs. I bet you wanted to talk about cloud-based IDs.
Yes, exactly. And it's really exciting to me to see the new Arduino IDE adopting the Eclipse Theia technology as their editor there. That's not cloud-based necessarily, but it's great to see a lot more of that stuff coming into some of the IoT space or the electronic space. But yeah, I think the fact that you can just easily share some code that you're noodling on to something like GitHub and press dot and get a code space, press period, I should say, and get a code space and start building on that is really cool.
Yeah, and plus, I think it's a great bridge also. Like when you get to a point where the emulation/simulation stack is reasonably complete, then like you have a clear path from being a hobbyist, or at least like doing some POC. You're waiting for your dev kit that has like 52 weeks lead time and things like that. You're starting to tinker, but actually you're not too far from like building a real sort of industrialized kind of project where yes, it's on GitHub, but you also have like CI/CD, right? You can actually test and like build your IoT project and not only check that the code compiles, but also run some unit tests and integration tests against mock peripherals, right? Like you have some kind of HMI, some kind of GUI on your IoT device. Well, like the tools are there already to be like, hey, I have a small LCD display. Please, emulation tool, please Renode or please Walkway, run my code, and after 5 seconds, save the PNG file, like the image of what is on the screen. And this could be part of like one of the artifacts that you have as part of your like continuous integration and continuous delivery pipeline, so that you can check that things are working the way they should, right? You can compare the image to some kind of reference. You don't need the hardware, because like I have some colleagues building some like test farms with real IoT devices. Sometimes they're not so happy to have to maintain
I was just, while you were talking, I was just thinking about that, because the problems I've had in the past of testing implementations, and revisions of software for embedded devices is just, it's really difficult setting up. So some devices you can't automate even loading the programs onto. So having some simulation where you can do that all automatically would be really helpful.
And coincidentally, that's a very important concern for our cloud development tools working group at the Eclipse Foundation. They have an embedded special interest group where they discuss questions like that. And one thing that we've seen coming out of that recently, I think there was a demonstration from an Eclipse Shea contributor at the Open Source Experience Conference last fall in Paris, so close enough to you, Benjamin. And I think that the demo was literally Eclipse Shea plus a kind of little browser plugin to be able to plug the board, and using a Red Hat project called Drogue IoT in Rust, they were able to program the microcontroller, and then, from the same web-enabled workspace, work on the embedded code for the microcontroller on one side, and then to have the web application or the web platform in Rust on the other side as well. So it's all coming together, so to speak. And I'm glad that you mentioned Theia, because Theia is at the center or the forefront of that, in the sense that, yes, it's been used in the embedded space to build the new Arduino IDE, but we've seen cloud platforms emerge around it, because it's both a desktop, it's something you can embed in a desktop application or in a web application at the same time. So it's great technology for sure.
Honestly, I just smiled when I started using and testing out and beta testing the new Arduino IDE, because I've been involved in the Eclipse ecosystem for such a long time, both as a contributor and before that, just as somebody who used the original, the classic Eclipse IDE, I should say, and all of the different projects. It was really exciting to see the ways in which software cross-pollinates through different parts of my life. It's really cool.
One potential thing to take also into account when working with hardware is the existence of FPGAs, or field programmable gate arrays. Essentially, a software-driven chip that you can reprogram in order to play around. And in the Eclipse ecosystem, there is something called the Open Hardware Group. They are working on RISC-V based processor cores that are open source, and you can download literally the source of the processor core from their GitHub site, and then simply deploy that on an FPGA and play with the chip, and maybe, if you're good enough, modify it and test your revisions like that. So do you see that working with FPGAs as a growing trend, in the sense that you can push revisions easier for hardware and things like that? Do you see that in your respective environments?
I would say not so much, not yet, but it's only like an interesting trend for. There are some like specialized applications where they're just like the hardware doesn't exist, right? In terms of, you need really high throughput for, tapping into the car's like telemetry system, and you need like to pretty much build your own microprocessor or your own brains. And so, yeah, I mean, FPGA and sort of software-defined hardware, if you may call it that way, is definitely useful in that sense. Yeah.
I've only really been, I'm using chips now that are FPGA and RISC-V and families, but the only experience I have directly of seeing them, fulfill that promise is in the gaming context. So there's some games hardware that you can build for yourself based on an FPGA that literally will reprogram the chip or reconfigure the chip to be a Nintendo Entertainment System with all of the original foibles and weird things that used to happen. So there's a project called Mr., which I will find a link to and drop into the chat if anybody's interested in building something like this. It's kind of cool that you're not just running a software emulation on top, on top of Linux, on top of an ARM or Intel chip. You're actually, going all the way down to the hardware level. It's a fun project.
And I think in the FPGA space, we've seen Intel and AMD making acquisitions directly targeted at bringing more together general purpose processors with FPGAs in the same, not necessarily the same chip package, but at least, bringing those technologies together. So there should be interesting developments for sure in that space. All right, getting to our third theme in the interest of time. So we said that the third major trend that we will discuss are emerging languages, emerging platforms that really support the standards and protocols that are out there. And there are a few names that we put on our list of topics. So instead of me spoiling everything by naming them, so maybe we can ask each of you to pick one or mention one that you find interesting that people should pay attention to. So maybe we can start with you, Jan.
I was going to say probably not me, because that was the list of languages down there was suggested by the other two. So let's go with one of the other two first.
Absolutely.
Andy, you go first.
Okay. Well, I think I jotted all of these down into our joint notes, but I'm happy to talk about any of them.
I think my point is not in our notes.
Most importantly,
yeah.
Okay. Well, first of all, huge respect to Ian and his C and C++ knowledge, because those languages are definitely not going anywhere, and are in fact just becoming built upon increasingly. But I've become personally much more involved with the MicroPython project, which I came to via the CircuitPython project, which is a sort of consumer-friendly fork of MicroPython that Adafruit, who provide a ton of different hardware. Coming back to Benjamin's conversation, and this is what I actually intended to say earlier, around all the components and all of the sensors and so on that you can plug in. Adafruit have taken MicroPython, built a ton of, and made it very user-friendly, so it appears as a USB device when you plug in your board and you drag and drop your libraries. The core MicroPython project, and I've been talking to the folks there a lot recently, and I'm going to be doing a two subgroups, I think next month, or maybe this month now, and we just slipped into March, is really interesting to me, partly because Python as a whole, I think, got a huge shot in the arm from becoming the sort of default language for the Pi. So you've had a ton of people grow up on Python. Obviously, we've got Python implementations of Paho and other protocols already. There's a MicroPython implementation of MQTT, which works very well. I've used it. I've built a little cheer lights display using that on ESP32. So I'm really interested to see what happens around MicroPython. I think it's a project that needs a lot of, or could do with support on the tooling and on the documentation and the getting started side. But it's, you can take most MicroPython and run it on a full Python interpreter. It's really cool. So I will shout out for MicroPython on my side.
Yeah, and on my side, and maybe this is where I'm just like getting older, but I'm excited about what's happening in the sort of tiny languages spaces. But it's also like, I think getting to a point where we don't have to write any code is where I would like the industry to be, right? Because most IoT solutions, like at the embedded level, yes, they might require some really hardcore optimizations in terms of making sure that you don't like drain the battery and things like that. But oftentimes, like the kind of data you want to extract, it's pretty straightforward, right? It's a pretty simple, like I want to pipe this temperature sensor data into maybe some kind of signal processing algorithm, like I mentioned earlier, but like I don't necessarily want to write it, right? I will just consume it, and I want to route the data to the cloud, right? And getting to a point where you do this in a low code or no code, as they say, kind of approach, I think is pretty interesting. And there's you mentioned some tools, Andy, that do just that. There's also like I think Seed Studio has been working on Codecraft, right? And really like just you literally don't write any code. You have a rich enough framework that supports already most of the use cases in terms of just like taking components and wiring them up to one another. And one reason that I think we should have like this, at least as part of the tools available for developers, or like not developers then I guess, is I mentioned like this sort of pet project that I've been working on for the past few months now, right? I mean, I ended up sort of building some kind of tiny ML, so AI running on tiny devices, tiny ML based artificial nose, and it's pretty silly in many ways, but it's also a great sort of showcase of what it means to do IoT. Yes, it's using the Weo terminal that you're also holding, Andy. I wrote the code. It's pretty ugly code. I could have certainly done better, but it would still be code at the end of the day. And a few weeks ago, I was contacted by a really young kid, actually. He's called Caleb, and he's 13 years old. And he took the project, and he managed to reuse it to train this device that uses gas sensors to detect the markers, the volatile organic compounds that are markers for fungal pneumonia. And so it's like was built like something really, really good. It actually was on the front page of Hacker News last week, which is totally deserved for Caleb. But now, and so he's obviously really smart. He's been able to navigate around the project, but without touching any line of code, because he is 13. He hasn't learned programming just yet. And so now is like sending me tons of questions to be like, how should I go about getting started with programming? And yes, to Andy's point, like I will most likely point him to MicroPython, and he will learn like very useful skills for sure. But from what I understand, and he's probably way smarter than I am, but from what I understand of what he wants to do next, I don't think he needs programming skills just yet, because he's just in the process of mashing up data coming from sensors, feeding the data into machine learning models, but those are essentially just black boxes, right? He doesn't need to write those. It's just he feeds data. There's raw data coming in and there's insights coming out, and he then needs to route the data to the cloud or display the data to some kind of LCD display for user feedback. But it's not really programming, or at least I think there's a path where he doesn't have to write any lines of code. And so I think it will be interesting to see whether, although the devices remain constrained, although they need to remain customizable, can we get to a point where, we can configure them rather than program them, right? Because oftentimes that's what it's all about. Just like you write macros in Excel, or just like you hack around some. Yeah, I mean, I think you guys get the idea.
And there are middle stages to that, aren't there? It's in between where you get flow programming languages like Node-RED, where you might concentrate on just putting the blocks together, or go into the nodes themselves.
Yes, if you need to, you can have one of the key elements of your solution where you're going to write the code, but most of the orchestration is really just configuration. Yeah, that's totally very good point. And Node-RED is still definitely part of this galaxy of tools.
So I know we're short on time, Frédéric, but I'll just say that it's
Go ahead.
I'm very interested in other languages, and I would not be stuck with C forever if I weren't supporting a whole bunch of people who were using the code that I'm using. And Rust is an obvious sort of replacement for C in terms of a systems programming language, which I haven't had time to learn yet because I keep having to support the C code that people are using. But one of the colleagues of mine on the PAHO project has written a Rust client for MQTT, but he's written it as a layer over my C code. So because that makes it easier to get up and running. So, some of the core code that we've got for IoT is going to be around for a long time.
Certainly, and at the same time, I think, generally speaking, not just MicroPython, but Python, as a market juggernaut is really there to stay for sure. I think on the PAO side, Jan, that the Python implementation of the MQTT clients that you've got is very one of the most active and alive at this point in time, isn't it?
Yes. Oh, it is. Yes. There's just two other languages that I'll mention. Apart from the cross-platform development for mobile devices, there's several toolkits for those sorts of things, which are very interesting. But two languages that I found interesting, which are not necessarily new, but like Lua is something that's, because it's can be applied in so many different ways and embedded in devices. I think that's still a very interesting approach. And Julia is pretty much like a high-performance Python. So both of those I haven't had a lot of time to explore, but they both seem very interesting, although not particularly new. So whether they will make it as new paradigms, I don't know.
And before getting to the next stage in our discussion, I would mention it's obvious, Benjamin, you're not, I would say that a marketer, because you keep talking about this AI Knows project, and I'm a bit ashamed you didn't come up with a catchy name for it, like Project Cyrano or something. Anyway,
it's
feel
actually
free to use that one.
Yeah. The name is, the one that's been suggested to me and that I kind of like, but still didn't get my head around actually using, is Nostradamus.
Oh, that's good. That's a good one too.
Someone actually bought the domain and gave it to me, so that was nice.
Wow,
that's a nice present.
Interesting. So certainly one story to keep an eye on or a nose on going forward. And congrats on what you've done there. It's great, awesome. Great material. All right, we've got a question from the audience, and I will say that it's not directly relevant to what you are doing right now or what you have been doing at Eclipse, but let's try to tackle it together. So Alex is asking about Kura and Kapua. So if you're less familiar with those projects, Kura is a Java OSGI framework to build IoT gateways, and Kapua is the cloud platform that goes with that. I simplify a bit, but let's say it's a good enough explanation. And Alex says that he recently joined a company that implemented a monitoring solution for photovoltaic panels based on this software stack. But at the same time, it seems that the community around the project is not as active as it should have been. There are lots of open issues, not necessarily always timely feedback. And well, he's asking about, generally speaking, the state of the project and what could exist as alternatives. Now, you've been U3 for a long time in our community, and I may have hypotheses about, what happened to Alex in his quest, let's say, to get answers to his questions on all of that. But given the feedback that he's giving there, what does a what is the best way to engage with our Eclipse IoT community, and what could we do differently as community members, maybe to better address situations like that?
So I'll say that I think a lot of open source projects are in the position of relying on a small number of key contributors, and that if they are pulled off onto other things, or circumstances in their life mean that they can't focus on that project so much anymore, then that project is going to lack that support. And so if as a community member you're making good use of a project, then these projects aren't particularly owned by any one person. That you should think of it more as being part of that, or a member of that project. How can I encourage it to keep going? And so the contributions that you can make, raising issues, yes, but if you can contribute PRs to make it easy and fix some of the issues, that especially the ones that you're interested in. If there is means to contribute by financial means, or if you're a member of a company that relies on this, trying to make some time and space for some of your employees to take part in that project and support it themselves. That support, that last one, is probably the most key. Because all of the projects start off and continue because there are very interested and committed people who are supporting it, whether they're employed by a company to do it or doing it on their own personal time. So as a member of a community, committing some time to help out a project is the most useful thing you could do, I think.
Yeah, and something else I think is, but I think, Alex, you certainly know that, there's no such thing as free lunch, right? And when you consume open source software, like it's what it is, but I don't think, like, if we were to look at something else than Eclipse Kura or Eclipse Kapua that you might be using in your company, like some kind of Linux distro, or like some kind of software that is effectively open source, but there is usually some kind of company that you actually pay money so that you are in some kind of commercial relationship with them, so that they will help you with like supporting whatever you want to do on top of the project. And oftentimes, I think when you source an open source project, like, it's either you want to be on your own and you understand that it might be harder, and the community upstream might not always be able to answer your queries, or you try and find some company and some partner that's going to be helping you with making it work in a more commercial and long-term and sustainable way, right? And I think that's how it works for actually many of the open source projects at Eclipse and at Eclipse IoT, right? There's usually companies supporting the project, and I think they are super happy if you work with them. Not that they want to take your money, it's just that they're genuinely here to help you, right? And to because you don't want to run everything yourself oftentimes.
And sometimes it's about interacting with the team through the correct channel, in the sense that for whatever reason, sometimes the developers don't necessarily see your particular GitHub issue, especially if you don't tag anyone on it. And they could be maybe more disciplined in looking at the list of issues, but for various reasons, it's not always the case. But the Kura and Kapua team, they have channels on Gitter that you can join in order to interact directly with them. That's one thing. And if you don't know where to look, well, that's my job as the community manager for this community to help you out. So I would certainly suggest, I'm putting the link in the chat, Alex, join our Slack workspace. And if you need anything, I can help you out, find answers eventually, or find the right people to talk to if I don't have the answers myself. But ultimately, what Benjamin and Jan said is completely true, in the sense that there's nothing actually free, and sometimes it's about finding the right business model or the right context to advance your own interests while contributing to the community at the same time. Finding the magical model where you get everything for free won't work.
It's always surprised me when I was working for IBM that people would create solutions using open source components and wouldn't think about. They assumed that this support was going to happen magically. But if it wasn't an open source component, they would look at what companies were supporting that hardware or software, and how much it would cost, and that would be incorporated in the cost of the project. But then they would forget about, say, Mosquito, and they just say, oh yes, we're going to have Mosquito as an MQTT broker, and forget oh, well, maybe we should think about some cost of support for that as well, you know, and finding somebody who would support that for us, or having somebody on the team that we pay who would help out with the support and contribute to the Mosquito project. Either would work, you know. So I think it's important to think about that for open source projects as much as any other, or components as much as any other.
That makes sense. We are at time, so unfortunately we'll have to cut this conversation short. Before we leave, however, we wanted to leave you with a little gift in the audience, and essentially what I'm sharing here are themes or things that are happening right now that we felt in preparing this panel that you should pay attention to. One thing is the EU Data Act. Essentially, new regulations and laws are brought in the EU that will potentially give users more access or full access even to the data generated by the IoT devices that they have in their homes and in their lives, generally speaking. So certainly, if you are in the IoT market, that's something to keep an eye on. Another thing, which is maybe more North American centric, but still relevant, is what we call, for lack of a better term, did you want to say something? Okay, for lack of a better term, IoT security labels, in the sense that increasingly we'll see in the market a push for IoT devices to disclose what kind of hardware they have to monitor the environment and what kind of features are enabled by that. So once again, if you're working on solutions, maybe it's a good idea to start thinking about how you can better disclose those things and not pull surprises on your customers or partners where magically, hey, there was a camera or microphone in there and nobody knew about it. And finally, open source hardware is certainly a growing trend, and pay attention to the Core 5 MCU literal hardware. Right now it's on FPGAs only, but you will be able to buy actual hardware later in the year. And you know, there will be announcements by Open Hardware Group around that. But generally speaking, open source hardware is certainly something to keep an eye on. Now, my call to action to you in the audience, you know, and thank you for being here with us today, would be first to use and you know, our technologies at Eclipse and contribute to them, and not just Eclipse, but there's great open source IoT and edge technology, you know, in the market right now. So, you know, don't just download, but push PRs, push contributions, whether it's documentation or something else. And in our case at Eclipse, you can look at ioteclipse.org/projects in order to see all the projects you can benefit from. Our 2022 developer survey is coming, so it moved around in time, but this year we are doing it from roughly speaking March to June. So stay tuned for announcements when the survey will be open, and thanks in advance for participating. And finally, the call for papers for EclipseCon 2022, our annual in-person conference, will open roughly around April 18. The date could shift by a few days, but stay tuned for that. So if you want to share your IoT knowledge and expertise with the rest of the market, then please submit a proposal for the conference. And that's it for the call to action. So I think at this point, the last thing left is to thank our panelists for today. So Andy, Jan, Benjamin, thank you so much for participating and sharing what you know with our audience here. Really looking forward maybe to future editions of this panel. I think there are so many things we could have talked about, and you know, we could have easily filled 2-3 hours worth of content with the three of you. So thank you so much for your insights. And to the audience, well, stay tuned for the next episode of The Edge of Things. We don't have a date yet, but we are working hard on scheduling that. So you should have an announcement coming from my friend Hassan here shortly. So any last words before we close this broadcast?
Stay safe, everybody.
Oh,
yeah, stay
yes.
safe, and thank
Yeah.
you. Thank you for hosting,
Good one.
Frédéric, and organizing. Appreciate it.
Well, you've been a joy to work with. So, you know, it's not work when it's actually so fun. So, you know,
Thanks.
I'm glad to have I've had the opportunity to monitor, but not monitor, but moderate this panel today. So thank you, Andy. All right. So if there isn't anything else, thank you again in the audience, and see you next time at the next episode of The Edge of Things.